Um, I think that's better. Okay. So thank you for this opportunity. So the idea for us is just to show these preliminary results, what we are doing in this moment regarding this subject. This is a specific work of Amazon conservation in Peru. Um, so at the last of the presentation, we have a lot of questions, or some specific questions about how we can improve this work. About logging activity, this is a specific, especially here in Peru, in the Peruvian Amazonia, is different. For instance, from the logging activity in Brazil. In Brazil is more big scale. Here is in small scales, and many times it's different. It's very complicated to identify, to detecting this activity. So this pass all the time under the radar, like we say here. Um, we start to tracking this activity since 2017, 2018 approximately. And these last 2 years, we can push more, or we can invest more resources because we can have access now to this SkySat constellation, and it's more cheap than other resources like Worldview or GUI. This activity is very difficult to detect with using Sentinel-2 or other resource. But we choose this example that is maybe is a logging activity, a medium scale. We can say that it's not a small, specific small scale, but we can represent very well. We can see very well what is the pattern of this activity, of this patch. So this is all the steps of the monitoring cycle for detecting any kind of activity in the Amazonia. The specific case we will present is the case of Fatima, but we have many other areas of monitoring logging activity. We can show this because this is public, and the other data is now we can say this is are in a process of investigation, research, something like this for the prosecutors and the police. So we cannot share this data, but there is no problem with this area. So we detect here a lot of pointers of logging activity, and also some routes, and this is an example of the last week. We have a team to go to a team who went to the field and just make some fly with a drone and take the image. For make this comparison, what we see in the SkySat data and what we see with an aerial image, with a drone. We can see that this is very small patch. If we see this in, like I said, in Sentinel-2, is very complicated. Specifically, this is because you can see just two small patch in all this space. So this is an example of what you can see in the field. How is the intervention process, and all the resources we have to start or to detect this activity. Of course, Colab, TensorFlow, the machine, Google Earth platform, the Google Cloud platform, and the Google Earth engine. Until this moment, we make more of this activity based in machine learning, and or sometimes just with a digitalization process. So this is no, we don't have a better resource than this, and this at this moment. So the idea was to start to detect in the with a better resource, with a better tool. That's why we start to work with deep learning. Just at the first time, just using all the data, all the points, all the tracks that we have. And now we start to improve a little bit more this source. No, we are trying to build a benchmark data set for a better process. So I'm just showing some image how you can see this activity, or what is exactly the patterns we are searching. The paths of logging activity of the camps, so very small. You can see this just hiding in the Amazonian, and the steps for this new activity that we are doing in this moment. No? So the first step, is the benchmark data set. So we have a benchmark data, but we just have points know exactly the area. No, the idea was the idea is to apply a semantic segmentation process. So of course, the resource we used was Google Colab, Google Platform, and Google Earth Engine. Osmar, I will let Osmar explain a little bit more how we are working in this moment with these steps.
Yeah. Hey everyone, thank you, Lucio. I'm going to be talking a little bit about our benchmark generation. Currently, we have started gathering a small team, and they are right now generating our benchmark that in the future will be used to feed the neural network. So, in this stage, we have selected some sections of Sentinel-2, Planet NICFI, and SkySat imagery. We have cut some small pieces and we have given these patches, these small portions of images to our team that they are manually digitalizing these selective logging activities. Next one, please. Okay, so the next step, when we have gathered our benchmark dataset, we're going to be building our model, and after the building is complete, we'll be training it. So this we have researched a lot about different deep learning models, and we are considering the UNet convolutional neural network to make predictions about selective logging. And our final step would be applying this deep learning model to our different case studies so we can scale more with more data, because traditionally these predictions were done visually and it was pretty time consuming. Next one, please. And this is one of our preliminary results with Sentinel-2. On the left, you see a Sentinel-2 image, and on the right, you see our training data set that we have gathered over the months. Next one, please. And these are some of our predictions. You see that this pattern that selective logging generates, it's pretty close to logging roads. And next one. This is the case that Lucio explained in the native community of Fatima. And these are some results with Planet NICFI imagery. On the right side of the screen, you see the predictions being done by the neural network. Next one. And this is the stage we are right now. We have, like I said, we have gathered a small team, and they are manually digitalizing all of the login cases that we have gathered. Next one. And these are some of our questions. Our main doubt is how can we improve for this process of benchmarking? And what would be the recommended patch size for feeding this neural network in this specific case of login activities? And if you have some recommendations for architectures for transfer learning, that would be pretty helpful.
Yeah, thanks, Osmar. So, Tim, sorry, the time. No, this is now a ended product. No, we have. But so we are on the way. So of course, all this activity started, in the last year, presentations and all the meeting we have. So if you have some recommendation, we will be very helpful. I don't know. I think that's all. Thank you.
Thanks so much, Osmar and Lucio. I mean, first off, I thought you guys were going to be giving a presentation on what you plan to do, and here you are presenting results. So I'm pretty blown away. I mean, it seems like you guys are. When do you sleep? First off, because this is really great. Great lines of questions here. And before we hop into that, I just want to make a comment. We had been chatting with Sam Roy from Planet, and he is in the process of putting together a blog series that interviews end users who are using the NICFI data to come up with useful efforts for using the NICFI data. And I think that this might be a perfect candidate. There's an opportunity here to sort of capture your guys' use. And I know, Helen, you're on the line. I don't know if this is something you guys had chatted about before, but I do think that this might be a good candidate. And I'll pause here.
I haven't had the chance to chat with anybody, but this is, I'm really excited to learn more about this project. Thank you. And happy to chat.
Great. Yeah. And I mean, I don't know necessarily the next steps on, I think maybe it's, we just talked to Emil about folks' interest in potentially highlighting this work, but it's great to see the use of this NICFI data. And on that note about sort of the comm side, before we get into the technical part, I think this also could be a good candidate to sort of highlight through Google. Obviously, we need to do a lot of validation and talk about the product, but these are really exciting results already. So I'll put that bug in your guys' ear. So if you want to go back to those questions, and I'll pause here and maybe tee it up for the rest of the folks on the line who've been maybe working with Planet data, and maybe have more insight about some of these recommendations. Maybe I'm thinking towards Ate and Nien. If you guys have thoughts that might be useful to the team in Amazonia, I'll pause here.
I was waiting for Ning to pitch in. So we usually use different strategies. How many samples have you been using for training the model, the CNN model here?
I don't have exactly the name, but Osmar, this is about the result, the preliminary results of about this new strategy, this new step, this new digitalization process.
I think it was over 300 login points in this specific case of Fatima. Yeah. And like more than 700 points in other regions.
Okay, so that is the number of polygons that you use to train the CNN, right?
Yeah, we use the point as reference, and after we make some we build some patch, but small patch around these points. All the time that we mark these points, we try to do this in the center of the polygon, but we didn't get exactly. So we didn't have exactly the polygons. That's why we start this new. We will say this is new step of digitalization process. Now, for this digitalization process, we are associated with University Agraria La Molina here. We are working in this moment with a group of students. This is now a more complicated activity, but we want to be sure that we are working in the right way.
I think that way that makes a lot of sense. We actually for Cambodia, we use a very similar approach of using a CNN for mapping forest disturbances. In our case, we use Sentinel-1. And one of the main issues that we had was also that we lacked sufficient amount of training data. So one method we often apply is that we sample the patches that we have from different positions. So that is a way of increasing the number of patches. You can also flip and rotate the patches, so that also is a great way of increasing the number of patches. But for our case specifically, we also use the GLAD dataset for creating a synthetic data set on forest disturbances, and that turned out to work actually quite well. I see you have your hand up, Tim.
Yeah, so you mentioned the migrating of like the pixel center and the flipping, and is that Jack's approach? Just so I know that
Yes, yeah.
Okay, yeah.
Yeah.
Lucio, let me send you the link to Jack's slides back from the last TensorFlow Technical Exchange, because that might be a good resource to just get a sense of what Ate had just mentioned. I'll pause real quick.
And also the method that we applied in your paper, Tim. So we used the GRC data to create basically a synthetic service water layer to train a Sentinel-1 model. And then I think for the last question, for the second question, in terms of patch size, we often work with sizes of 128 by 128 pixels. I think in most examples, they also use 256 by 256 pixels. Our finding is that both pixel sizes work really fine, but for computational efficiency, we often stick with 128 by 128. And for transfer learning, there are actually, I think, two ways of transfer learning. The first one is model transfer learning. So you can take a model which already has been trained, and we had some previous presentations on that as well. What is the name of the website, Tim?
For the landing page?
The landing page, but also the presentation on transfer learning for Sentinel-2, Landsat 8, where we can find the different models.
Are you talking about the sugarcane transfer learning approach?
Yeah, we used the RGB channels, but there are more repositories now where they have different the different channels of Sentinel-2 and Landsat 8 as well. Let me dig it up. Sorry, it's late here.
Sorry, I'm fighting my computer right now to also just share this link. But so to that question about model architectures, also, I mean, obviously the patch size is so linked to the architecture as well. Trying to bring Nian into this conversation as well. Just thinking back to your Sentinel-1 process and those really great slides. Do you think there's any kind of recommendations that you could provide to the Amazonia team? So I think there's a lot of symmetry here. And Lucio, would you mind going back with that question in mind about architectures of, I think you had a picture of a UNet. Is this maybe just a tentative plan? Or is that sort of where you've gone thus far and you're looking more towards either changing architectures or maybe how to further parameterize?
Tim, in fact, this is a question that we are now answering this moment. I know we get for the previously examples we just show in this presentation. This is we get some examples where you did in the past. Of course, that transfer learning for the deep learning for water monitoring, something like this in a previous training about hydro fluid, something like this. Do you remember? So we get some of these ideas and also other presentation, and just we get the data, we put the data, and we run this process. So I think this was I don't remember exactly what is, but in theory we need to work with the UNet. This is the idea, and we try in this moment to solve a process. The previous result was just an example for showing what we can get, getting all the data and just running in this with these scripts, no. And this moment we are now start to working with this SkySat. Our objective is just a SkySat, very high resolution image. The examples previous result we showed was with NIC-FI and with Sentinel-2. This is important to mention because SkySat is, in fact, this is a very complicated. It have a lot of problems. This kind of data. It's very high resolution, but for instance, the geometric correction is a nightmare. No, you know the point are we have a point far from 200 meters from the real real. So I know this is all. We have all these limitations. But in exchange, we have a very high resolution image. So that's why we need to start again or to start improving this digitalization process. So I don't know if I can answer this question.
Yeah. So if you're thinking about going back to the drawing board just to sort of rethink on the process too, maybe let me just toss out this idea. Maybe look to use like the YOLO model to do just object detection. Since, as I understand it, it seems like you're just trying to find those selective forests. And it seems, I mean, you did have that one image of sort of like a linear feature, which might be harder to detect. But if it's like individual patches, maybe a lightweight model to just do a bounding box might be a good approach too. And I'll see if I can find some resources to share. That's totally going in a different direction. But that's something that our TensorFlow group really hasn't even dug into yet. So that might be worth just exploring just from, a value add component.
Yeah. If, I think that could be interesting. So for instance, we are sure that we will test this just for object detection, the data of the camps, this small structure. I think this is not possible to apply semantic segmentation. So that we are okay if we can detect just where is this camps, because there are many components associated to this activity. So the camps is one of these. So the idea for working with this for deep learning is to try to go fast in the analysis. For in this moment, for analyze this and do one SkySat image, we spent a lot of 1 day, 2 days. It depends, because if we are very busy, we don't have a team for making this activity. So 3-4 days. So we expect having this deep learning model, we can make this fast just in a couple of hours, and maybe have another person just to check the results and to know what is exactly the alert, because all this data we send all this data to the prosecutors and the police. So we need this interaction, very a very fast interaction.
Okay, well, I know we've got Tanuja also to present right after this. Oh, thanks for sharing that, Ate. I've got it as an action item. Lucio, if you could share your slides also. Some background on the YOLO model, the video from Jack and about his pixel flipping, to get more looks. I think that could help to improve your sample size and lower the level of effort too. That might lead to some model improvements. And I'll follow up about the blog article as well, sort of just a long distance look. But thanks so much for the presentation. And let's also just chat about, maybe representing to the group in a few months as you try out some new things. Okay, I'm going to stop